In this session, we are going to learn the most basic machine learning technique called linear regression. In linear regression, we are given n data points of the form xi, yi, where in general xi can belong to d-dimensional space and yi will belong to set of real numbers, and here we will consider the case when d is 1, so xi will also belong to set of real numbers. Here xi is our input variable and yi is output variable or response variable, and what we want to do is, given some new x, we want to predict the corresponding value of y, and we do that by learning a regression function y equals to fx, which takes x as input and gives y as output. So the first question that we should address is, when should we use linear regression, or what are the circumstances when linear regression will give us the best result? Is the machine learning technique, and linear regression should be used when we believe that yi and xi are related in a linear way. And how do we know that? That we can know by plotting scatter plot of y versus x. And if that scatter plot gives us a sense that y and x are related in a linear way, then we should go for linear regression. And if we get a non-linear scatter plot between y and x, like any of these examples, then we should not use linear regression. So in linear regression, we assume that the true relationship between y and x is of the form y equals to alpha plus beta x, and we want to learn this relationship. But because we are learning this relationship based on given xi and yi, our actual relationship will not be exact one, but there will be some error in that. So we write actual relationship as y equals to a plus bx plus e, where e is the error in our relationship, and here this a and b are called estimated values of alpha and beta based on given data set. So the error corresponding to ith observation xi yi will be, that I can write as ei equals to here yi minus a plus bxi, and our objective is to minimize the cumulative error for all the observations, and the most common measure of cumulative error is least squares error, which is obtained by adding squares of all the errors. So sum of squared errors will be sigma I from 1 to n ei squared, or that will be equals to sigma I from 1 to n yi minus a plus bxi squared. And this expression is also called the loss function or objective function. And our objective is to minimize the loss function, and for that we need to find values of a and b such that our loss function is minimum, and that we can obtain by setting partial derivative of loss function with respect to a and b equals to 0. Now, I will not do the full calculation here, but I will write down the final values of a and b. So b is equals to sigma xi yi I from 1 to n minus n x bar y bar divided by sigma xi squared I from 1 to n minus n x bar squared, and a equals to y bar minus b x bar. And here x bar is equals to 1 upon n sigma I from 1 to n xi, and y bar is equals to 1 upon n sigma yi I from 1 to n. Here note that the parameters b and a are obtained from our given data set. So This process of finding A and B in terms of given data is called learning the parameters from the data. And the data set used for learning the parameters A and B is called training data set. And the line y equals to A plus bx is called the estimated regression line for given data. And we can use this regression line to predict value of y for some new x.